Hey guys, welcome to my YouTube channel. I'm Sebat Adam, and I'm going to discuss the kidney disease detection project using the AI. First of all, kidney disease is a term used by the doctor to include any abnormality of the kidney, even if it is only very slight damage. Chronic is a condition that doesn't not get completely better. Some people think that chronic means severe. This is not the case, but often chronic kidney disease is the only slight abnormality in the kidney. Chronic disease is the major global health problem because in earlier detection of the chronic disease allow appropriate intervention, regular screening, and more. Especially for this disease, it doesn't show symptoms at the RA stages, but you have to use especially the urine and blood samples to detect whether your kidney is functioning well. And most of these are detected using the glomerular filtrates. The glomerular filtrates, we use that because it contains some sugar. If your kidney cannot filter well the blood, your filtrates or urine will contain a lot of sugar, and this will lead to your pain during urination. Then the open data set and how to be used. Yeah, I have used the two that in my open data set. In my data set, I have used two data sets, which I'm going to mainly discuss. So those are the texts and the images, and they are to be obtained from the participant or victims of the kidney diseases. The text include the symptoms and the characteristics expressed by the patients, and images shall be taken in order to determine the status of the kidney. In this case, the blood and the urine test shall be used to detect the perfect functioning of the kidney. And therefore we can need to study the disease using the retinal images and the clinical data collected from the patient. Factors considered before selecting my data set are, so first of all, we actually say the information collected from the patient should be accurate. In this case, it favors the precise use of the information to come up with a conclusion for the disease affecting the patient. Another one is ethics. There are several ethical issues to deal with, especially in the medical sector, which include the privacy of the patient, security, among others. It is more important to keep the information of the patient, and this information should be between the doctor and the patient. Relevance. This is we collected data for its use, meaning that the data collected should meet its importance towards the determination of the disease. Then quality. The information collected should be of high quality depending on the algorithm to be used. For example, if we are going to use the blood sample, we shall need little blood, but if we are going to use the urine, in that case, we shall need a lot of urine to detect if it contains a lot of sugar or not, so that we can deduct the functioning of the kidney. Then another important features in my data set, we know that as someone develop a high blood pressure, the amount of blood filtered per second reduces since a high blood is transferred from the body within the body at a higher rate, meaning that for this case, our functioning of the kidney will reduce since the amount of blood filtered per second will reduce. Then sugar. The amount of sugar in the glomerular filtrate determines the healthy status of the kidney. The healthy status of the kidney. When the amount of sugar is high in the filtrate, this implies that the amount of sugar in the urine will be high and hence staining of the urethra during urination. Then the next thing, another important feature is the symptoms got from the user. The patient may be experiencing some characteristics like back pain, high heartbeat rate, among others. If these are explained well to the doctor can come up with a conclusion to detect whether his kidneys are functioning well or not. Then, if you come to the albumin Albin refers to the abnormal presence of albin in the urine. Microalbin is considered as an absolute term, as there is no such abnormal molecule, and is so referred to as a urine albino. It is used to detect the the inconstant of nephew in the diabetes. Those are the people suffering with the scar, with the diabetes in their life, and this may lead to the poor functioning of the kidney. If we go further, we can look at the Bayesian theorem. The Bayesian theorem is used to determine the conditional probability given the other instance occurring. The other instance that given the other instance occurring is known. That is the probability of one event occurring given that the other event, and it's very easy known. For example, if we want to come up with the value of probability of a given B, we should be knowing the probability of B given A. That's all about the Bayes theorem. Under the calculation, we shall go further. For example, if someone is suffering from chronic kidney disease corresponding to one, if the chronic disease corresponding to one's blood pressure, then using the Bayes theorem, we can determine the probability of the chronic kidney disease more accurately with the help of the known value of the blood pressure, since both of the two are conditionally on the one another. Then you have the naive Bayes theorem. The naive is a supervised learning algorithm, which is based on the Bayes theorem because of the word Bayes theorem, and is used to solve the classified problems. It's more used in text classification that involves dimension training. The naive assumes that the occurrence of a certain feature is independent from the other occurrences, meaning that if someone has blood pressure, we can't, in this condition, we can't use the blood pressure to come up with the conclusion that someone is suffering from the chronic kidney disease. And for that case, we shall use a lot of calculation like explained this below. The naive sample is taken, constructing model. For example, a fruit may be considered to be an apple if it is red, round, and 10 meters in. A naive Bayes classification consider each of these features to contribute independently, meaning that this fruit is an apple, regardless of all possible correlations between the color. We don't consider anything on the feature, meaning that we cannot, if we go back to our disease, we cannot depend on the blood pressure or sugar to come up with the conclusion that someone is suffering from the chronic disease. That's all about the naive theorem. Then if we go to the Bayesian network theorem, the Bayesian network theorem represents a set of variables and their conditional dependencies. For here, we should have a dependent variable using a direct cyclic graph. A cyclic graph is a graph without cycles. That's following the graph from one node to another, which contain links we move from here to here, so that you can come up with a given conclusion. For this case, you can never meet the same node twice again in such a graph. The Bayesian network can be used to from data. The model consists of two parts. That's the dialectic acyclic graph and the table of conditional probabilities. The Bayesian network graph is made up of nodes and arcs. The arcs are the directed link which move from one node to another, and each node corresponds to the random variable. And the variable can be continuous or discrete. For this case, it can be varying from one case to another or to have a specific variable within a data set. An arc or direct arrow represent the causal relationship or conditional probability between the random variables. For Bayesian network theorem, it deals with the dependent variables for this case. Then the difference between the Bayesian theorem and the naive Bayes is that the Bayes theorem is used to determine the conditional probability. It means that to know the probability of a given B, we must be having another condition known for it to be determined for an event occurring. And as already for this case, its value should be known. While the naive assume that the occurrence of a certain feature is independent from another feature. For this case, we can, as I explained before, we can determine the chronic kidney disease depending on the sugar or blood pressure. For this case, sugar and blood pressure are independent on its own. And then you have the difference between the naive Bayes and the Bayesian network. Now, naive Bayes assumes a conditional probability. Z stands for prior probability. That's a probability which is before the condition. For this case, that's the value of Z. The value of X given Y, and the value of, for this case, X is the probability before the condition. For this case, the difference is that the naive Bayes assumes independent variables, meaning that for this case, it will be independent from other variable. We don't need to know any condition, any probability to determine the other. The naive assume that the occurrence of a certain feature is independent from other features occurrence, while the Bayesian network is the probability graph model that represents a set of variables and their conditional dependencies using a dialectic cyclic graph. But if this one is independent, then this one should be dependent, but this one should always be represented on the graph. Then these are the references for my work. This is the link for my data set. And these are the links where I have got some information from in the slides. Hello there. Thank you for listening. Subscribe, like, and share. Thank you.